Hi everyone. Today is another of our videos where we look at some machine learning algorithms from scratch. Today we are going to look at linear regression. We will try to use the analytical solution of linear regression in order to see how that works in practice with an actual Python code. This will help you understand how to code up machine learning algorithms from scratch, but it will also help you understand how the statistical formulas that we derive, how they work in practice. And again, I will take the risk of doing this live. Let's see how this works. So I will start with some imports. So the important import that I will need is to produce some random numbers. Okay. So I think I'll need to plot the okay. So with those, so the first thing we will do is we will generate some data points. So number of points, let's say we start with 20 points, okay? And then we will generate some random numbers, and this is why we imported rand. We'll just spread it out a little bit, and then, okay. And then let's look at what is the shape here. So as you know, in statistics, when we have to construct, so maybe we start by saying what we want to do. So we want to construct the X and the Y matrices. And if you are familiar with linear regression, you know that Y equals X multiplied by beta, and then we want to estimate beta equals x dx inverse x dy. And again, like, I'm not writing it in LaTeX, so please forgive me. And so we want to estimate this, and maybe we call that beta hat, and then we want to check if that beta hat is a reasonable estimate of beta. There is a separate video where I sort of go through the proof of how to prove this. But in this video, the goal is to sort of do this by hand in Python and see if that statistical formula makes sense. So we want to generate X, and the way to generate it is to add another column of ones, because this beta, in our case, is going to be two-dimensional. It will have a slope and an intercept. So in reality, what we want to do is beta 0 plus x multiplied by beta 1, and this is the x values. So we want to construct an X array, which is where we want to horizontally stack the random values dot reshape BTS1 plus we want the ones for the intercept, right? Should that work? Let's try. Okay. Will this work? Okay. What is the shape of the X array? Okay. Let's look at what the X array looks like. No, why am I doing that? Okay. It's one positional argument. Okay. That doesn't feel right. Okay. So it wants these in a tuple. Is that how I should understand it? Okay. So I'm going to stack these two. And then what's the shape of x? Okay. Okay, that looks reasonable. So I want two columns, and let's just check x, like just print x and see how whether that looks reasonable. Okay, so that's the column for the intercept, and then this is what the, okay. So let's start with a beta. So we will define our beta because this is what we want the beta to be, and then we will see if the estimate comes close. Maybe I don't know, just some random guesses. Okay. And so, and then our y val is equal to so x array in beta plus we will add some noise here, and so that's the epsilon, and the epsilon is location is 0, and the scale will sort of define how much noise there is. Maybe do that, and then size equals num ds, and then reshape this to match the okay. So that is the point where we want to plot. This is the second, I think I did something wrong here. Let's see. That's not what I had aimed to do. Okay, that looks reasonable. That looks reasonable. So now let's come to the meat of it. How do we estimate beta? So as I said, x dx inverse x dy, right? That is the what we call the hammer in statistics. And then let's see. And this is the meat of what I wanted to show in this video, is how do I estimate this in Python. So x dx, maybe I'll just make x dx. X dx is simply x and mul x so this is I want to do the inverse. Let me see, and then x d. Okay, maybe I'll just do it in just to make sure. So how do I do inverse in NumPy? np linalg.inf. Okay. How do I do the inverse in NumPy? I looked it up. It says np.linalg.inf. So x dx minus 1 is np.linalg.inf. So this is x dx, inverse of x dx, okay. And then x dy is equal to np dot, because I know I did the sizes correctly, this should match up. Y val, right? That should, okay. So then beta hat is simply the another matrix multiplication of x dx inverse and x dy. Okay. And let's see what is the beta hat we got. Seems to be a little bit far away from where we were, and that depends on the noise, but let's plot this. So y pred is simply x beta hat, right? That is correct. Okay, so let's plot this now. So the first thing we plotted was this one. No need for multiple lines here. And then maybe let's plot the same thing, but instead of the y values, the predicted y values, and let's just run it as a. Okay, that's not bad. That is pretty good. That is pretty good, although the numbers don't exactly match up. The estimates are a little far away from these numbers, but it's quite clear that the estimates are pretty good. If I make this very small, and this is probably something like if you do this in code, like these are things that you can verify. If I make this really small, now it's like almost like straight line, right? So the noise is extremely small here. I changed it from 5 to 0.5. Now I estimate these are very, very close, like 1.99, and this is like 2, and it says, yeah, so 2, it says 1.99, 1.3, it estimates as 1.27, and then if I do this, like exactly. So clearly the statistical estimate makes sense, and we can do like a pretty good job. Let's go back to this one, the final trick that I want to show you. Sorry. So I again changed it to 5. So let's go back and do everything again. And yeah, but what happens if I change this to like 200? And okay, so let's see how well. So now you see like our beta hat improved a lot, even if the noise is the same because we have a larger number of data points. It's exactly like 2.00, and like 1.38 is like a little bit off, but yeah. And you can see like it does a really good job of like computing the beta. So hope I was able to explain to you in this sort of live coding session how we can do, how the linear regression estimates that we derive in our statistics class works in practice, and it actually sort of does a very good job of estimating the slope and the intercept. Thank you. But if you have any questions, like let me know in the comments, and again, like please like and subscribe so that I can keep making videos about making sort of machine learning algorithms and statistics algorithms from scratch. Thank you.